Welcome students to the Basic Electronics lecture series. Today we want to talk about diode circuits and specifically half-wave rectifier. So let's directly go to the contents of today's session. As you can see on the screen, today's topic is diode circuits, in which we will discuss half-wave rectifier. So basically, what do you mean by diode circuits? So PN diode can be used to construct various electronic circuits such as rectifiers, clippers, clampers, logic gates, and so many. The word rectifier is quite familiar with all of you because you know that it converts AC into DC. The clippers, clampers, logic gates might be quite new for you. They will be discussed in detail when their turn comes. So let's talk about rectifiers in detail. So what do the rectifiers do basically? So the diode rectifiers are used to convert alternating input voltage into unidirectional output voltage, or in simple words you can say AC voltage into DC voltage, that is unidirectional. But the problem with rectifier is rectifier output will be never pure DC, it is pulsating DC. So if you want to convert it into pure DC, you require filter circuits as well as voltage regulator ICs. As you know, Zener as a voltage regulator, so there are some ICs using Zener diode which can be used to regulate the output DC voltage. So that means rectifier output will be pulsating DC, but you can convert it into pure DC by using filter circuits and voltage regulator ICs. So let's see the basic types of diode rectifiers. The first type is half-wave diode rectifier, in which the output cycle will have only single half cycle for one complete input cycle. So output will be half cycle for one complete input cycle. That's why it will be called a half-wave rectifier. Second type is full-wave rectifier. That means you will get two half cycles in one complete input cycle as an output. So that's why it will be called a full-wave rectifier, which has got two subtypes. First one is center-tapped full-wave rectifier, in which the transformer secondary will be exactly divided at the center to have two half voltage available at the secondary output. And next one is bridge full wave rectifier, which will use 4 diodes to make a full wave rectifier. So both of them will provide full wave, but the output voltages and DC levels will be different. We will discuss in detail when that term comes. So let's go for half wave diode rectifier. So all of you can see the circuit diagram of single phase half wave rectifier. Our input voltage is single phase AC supply. In India it is 230 volt 50 Hz. In USA and European countries it is 220 volt 60 Hz. So that is your AC input. It is given to primary of the transformer. Secondary winding of transformer and primary are not physically connected, but they are magnetically coupled. So this is the symbol for that. They are not physically connected, but they are magnetically coupled. And the secondary of the transformer is connected to a diode through a load resistance and ground. So across the load we will measure the output voltage of rectifier. What is the primary voltage? VP. What is the secondary voltage of transformer? Vs, and which is naturally AC, so we have written it as Vm sin omega t. So all of you need to remember what is Vm. It is peak value of secondary voltage. What is Vs? RMS value of secondary voltage. So Vs is RMS, root mean square, while Vm is peak value of the secondary voltage. N1 is to N2 is turns ratio of transformer. N1 are number of primary turns and 2 are number of secondary turns. So going into detail, you need to just recall the function of transformer, what it does. So basically, transformer can step up or step down the voltage, but in this case, in rectifiers, generally it will step down the voltage. So it steps down the line voltage into safe and low value voltage suitable for diode operation as well as rectifier output requirement. Suppose you require 15 volt output, 20 volt output, 50 volt output, then you have to naturally step down the AC voltage. So transformer in this case will generally step down the voltage. Now look at these two dots. It is called a dot convention. There are two dots on primary and secondary. It simply means that the primary voltage and secondary voltage will be in phase always. They will be in phase. That means there is no phase difference between both the voltage. If there is a positive cycle in primary, simultaneously there will be a positive cycle in secondary. And if there is a negative cycle in primary, at the same time there will be a negative cycle. So that means both the voltages are in phase, only value of amplitude will change according to the turns ratio. So that is called the dot convention. Now the transformation ratio of the transformer, as you know, it might be stepped up or stepped down. So what is the turns ratio? Primary voltage upon secondary voltage is equal to primary turns upon secondary turns is equal to secondary current upon primary current. So this is called transformation ratio of transformer. So if voltage is stepped up, then current will be stepped down, and if voltage is stepped down, current will be stepped up. That is the basic phenomenon of transformer, so that your output power remains same as input power. So everybody remember, transformer is not an amplifier because the input power and output power are same. So it is just a passive device. It is not an amplifier because the output power is same as input power. Only voltage and current will be opposite to each other. Now let's see the operation of this rectifier. So before I show you the waveforms, I want to just again show you the circuit. Suppose there is a positive cycle on primary side. So the step down secondary voltage has the same positive cycle. So this terminal is plus and this terminal is minus. So the diode gets forward biased and it works as a closed switch. So now what will the load get? If this is a closed switch, whatever is secondary voltage, same will be available at the load voltage. So that means during positive half cycle of the input, diode is forward biased and load voltage is same as secondary voltage. Suppose there comes a negative half cycle of the primary voltage. So we will get negative half cycle in the secondary. So this will be minus and plus. So diode gets reverse biased. It works as open circuit. So there is no current flow. That means load will not get any input. So load voltage or output voltage will be 0. There will be again a positive cycle, negative cycle, positive cycle, negative cycle, and cycles will be repeated. So how will your output look like? Your output will look like this. Just see. Suppose this is your secondary voltage because rectifier circuit input is secondary voltage. So this secondary voltage is alternating, whose value is Vm sin omega t. So I have written input voltage secondary Vs. It is periodic pi, 2 pi, 3 pi and onwards, where x-axis is omega t. So our output voltage, as I explained, during positive half cycle diode is on. So whatever is input, same is output. Input and output are same. Now during negative half cycle of the input, diode is reverse biased, off. So output voltage is 0. Again in positive half cycle, diode is on, so we get the output same as input. In negative cycle, output is 0 and cycles will be repeated. So input of rectifier is secondary voltage. And what is the symbol of secondary voltage? Vs, and value is Vm sine omega t. So again we need to be confirmed that Vm is peak secondary voltage and Vs is RMS secondary voltage. Peak in the sense the maximum value of the peak, either positive or negative. So whatever we understood, let's summarize. What happens during positive half cycle of the input? Secondary voltage. The diode gets forward biased. It works as an on switch. So output voltage will be same as input and it is shown in the waveform. Output is same as input. What will happen in negative half cycle of the secondary voltage? Diode gets reverse biased and it works as an open switch or off switch. So output voltage will be 0. As you can see, during negative half cycle of the secondary voltage, diode is off, so output voltage is 0. And the cycles will get repeated because it is a periodic input signal. So that means the circuit will continue to give you half wave output, because for one entire input cycle from 0 to 2 pi, you get only half of the output cycle. Between 0 to 2 pi, only half output is available. That's why it is called half wave rectifier. We get half cycle for one input cycle, so it is called half wave rectifier. Now let's derive what is our output DC voltage, or you can say average DC voltage. So the average output or DC voltage can be written as VDC. So now average will be always taken as entire cycle. So what is the time period of entire cycle? 2 pi. 2 pi is the total cycle of input. So average will be taken as 1 upon 2 pi. Okay. For one entire input cycle, what is my output cycle available? It is only available between 0 to pi. There is nothing between pi to 2 pi. So output will be available between 0 to pi only. So we have to add all the outputs between 0 to pi. That's why it is integration 0 to pi Vs d omega t. That means your input voltage d omega t. Mind well, we have written d omega t, not dt, because our time axis is omega t. If it would be t, we would have written dt. Okay. So that means DC voltage is 1 upon 2 pi, 0 to pi, Vs d omega t. Let's put the value of Vs as Vm sin omega t, d omega t. Whatever is constant, let's keep it out. So 1 upon 2 pi and Vm are constant. What is integration of sine? Minus cos omega t. Upper limit minus lower limit. So let's put the upper limit. Minus cos pi minus minus, double time minus will make you plus, cos 0. Cos pi is minus 1, so minus 1 multiplied by minus becomes plus, plus cos 0 is 1. So ultimately 2 will be cancelled. Output of half wave rectifier is Vm upon pi, and if you put it 3.14, it will be further simplified as 0.318 Vm. So you can remember this, it is output of half wave rectifier. It will be Vm upon pi or 0.318 Vm. And you need to remember what is Vm. Vm is peak voltage of secondary. Vm is peak voltage of secondary. Another parameter that you need to take care about is output frequency. Now just see the waveform. The input cycle ends at 2 pi. The output cycle also ends at 2 pi. Though your output is only up to pi, but the other portion is 0. That means another cycle starts after 2 pi. So that means you can say input frequency and output frequencies are same, because input cycle also ends at 2 pi and new cycle starts after 2 pi. Likewise, output cycle also ends at 2 pi and new cycle starts after 2 pi. So we can say that output frequency in half wave rectifier is same as input frequency. Now let's take one numerical example to strengthen the logic behind half wave rectifier. So suppose the data is like this. For a half wave rectifier with transformer primary voltage 120 volt 60 hertz and a turns ratio of 5 is to 1, calculate output DC voltage and output frequency, and you have to consider second approximation of diode. So you know very well what is approximation of diode. So let's note down what is given. We are given primary voltage Vp is equal to 120 volt. That is fine. What is turns ratio N1 is to N2? 5 is to 1. So you can say it will be step down transformer. So what will be secondary RMS voltage? Equation was Vp upon Vs is equal to N1 upon N2. That's why Vs will be N2 by N1 into Vp. So that means Vs will be 120 upon 5. So secondary voltage is 24 volt. So everybody just be clear that this is secondary voltage, but it is RMS voltage, not peak voltage. And to find average value, you must have peak voltage. So let's convert this secondary RMS into peak. So therefore, what will be secondary peak voltage? So as you studied in physics, what is RMS and peak relation? Vrms is equal to Vm upon root 2. This is a famous result. RMS value is equal to peak value upon root 2. So what will be peak value? It will be root 2 multiplied by RMS. So that means peak value will be root 2 multiplied by RMS. What is RMS value? 24. Just multiplied by under root 2. We will get peak value of secondary voltage Vm is equal to 33.946 volt. That is fine. Now let's find output DC voltage of half wave rectifier. So we have the equation VDC is equal to Vm upon pi. But you are told that you have to use second approximation of diode. Your diode is not ideal. Your diode has a barrier potential of 0.7 volt. So that means that particular voltage will be used by diode. So it must be subtracted from the input peak voltage. So what will be the equation of VDC? Not only Vm upon pi, but Vm minus 0.7 upon pi, because it is second approximation diode. If it would be ideal, then direct equation would be Vm upon pi. But our diode is second approximation diode, so it is Vm minus 0.7. Let's put the value of Vm 33.946 minus 0.7 upon pi. Our answer would be 10.587 volt. So this is average value or DC value of half wave rectified output. I want to show you again the DC value of the output voltage in the waveform. It was 0.318. So it is shown as a dotted line, you can see. Your output is pulsating, but if you take average VDC, then it will be around 0.318 times Vm. This is Vm and it will be 0.318 times Vm. So it is not equal to Vm, but it is 0.318 times Vm. So in our example, our output voltage is what it is? 10.587 volt. What is output frequency? So you can say input frequency is same as output. So F output will be 60 Hz. So this is all about half wave rectifier and its operating principle. So I hope it is clear to all of you. In diode circuits, today we have only discussed half wave rectifier. We will discuss the full wave and bridge in the next lecture. Till then, have happy learning. See you again.